Hey everybody, like I said, my name's Matthew. So I've been an iOS developer since 2009. Like I said, I did a detour as a product manager. I'm still currently on that detour, part-time I guess you could say. And then I've been a part-time indie developer since about halfway through last year again. So before being a PM, I was a dev, and then I've come back to that. In this app that I'm building, I am using CloudKit, and I found it to be great overall, but I also found some shortcomings that I needed to overcome in order to be able to use it the way that I wanted to, and I think they're pretty common to most people's usage. So as every developer ends up doing when they're not being very wise, I decided to start making a library to kind of encapsulate those common solutions and make that available, and that library is called Mist. So tonight there's going to be 6 parts to what I'm chatting about. The first one is what is CloudKit and why use it. Then we're going to go into CloudKit's architecture, kind of what you can store in it and how it gets stored, where it gets stored, how to interact with it. Then we're going to actually go into using CloudKit in your project. This is how do you create a record, how do you save a record, how do you delete a record, how do you fetch records, just kind of the basics of doing that. We'll talk about why it's still kind of annoying to use and what some of the problems with it are. We'll go through kind of at a high level the library that I'm working on and the way it tries to solve those problems. And then we'll go through and answer any questions. And of course, if you have questions throughout, happy to answer them then as well. So we'll start with what is CloudKit and why would you want to use it? So I'll talk about each of these points more in just a second. But first of all, it is an Apple product, so to speak. It's a database as a service with a just-in-time schema. I'll tell you what that means in a second if you don't know. It supports the Apple ecosystem of products, as well as front-end web, and has REST API to access certain parts of the data. Has a built-in user system with automatic authentication. It is largely free. So we'll go through each of those points in more detail. So Apple product, what do I mean by that? By that I mean it is built and supported by Apple and provided by Apple to you. And they use it, importantly, they use it for their own products. So the iOS Apple News app is built on top of CloudKit. The Photos app, so synchronizing your photos across all your different apps, as well as iCloud Photos Stream, is built on, I believe, CloudKit. The new kind of revamp of the Notes app across all the platforms is built on that, including the latest version. You may or may not know, you can create a note, share it with others, and collaborate on that note. That's built using the latest kind of advancement in CloudKit, which is CloudKit sharing. I'll only talk about that very briefly tonight, but it's super cool and worth learning about. So given those facts, that means that Cocoa-powered products get really great first-class support, which is not always the case with competitors. It's an API that's fairly familiar to Cocoa devs, shouldn't be too mind-blowing. And I think most importantly, it won't be acquired and shut down, like Parse was. But I mean, even others besides them, and even if they aren't shut down, sometimes the focus sort of shifts out from under you, and it's always kind of a risk to build one of your products on top of these other products in case they change too much. But since it's built by Apple, provided by Apple, and even though it does support their products really well, not even though, because it supports their products so well, it is almost a little bit of a lock-in to the Cocoa world. So those are all reasons for them to keep it around. So I think you can be fairly certain it's not going to disappear one day, anytime soon. Okay, so it's database as a service with a just-in-time schema. That means it's a database for your app stored in the cloud. It supports storage of records, just like in a normal DB, so rows in a database. It also supports relationships between records, like most databases, and file storage. It doesn't support free-floating files, it doesn't sound like an S3 bucket. You can associate files with records, and that causes them to be stored. You can configure, I keep looking at the next slide instead of the current slide, sorry. So the schema for your app is defined in one central place, and you can configure that schema either by saving records or by configuring it in a web dashboard that's provided to you. And that's what I mean by just-in-time schema. So, with many databases, you have to kind of carefully plan your schema out, design it all at once, and then start using it. If you ever want to make changes, then you have to kind of go back and make changes. With CloudKit, until your application is in production, you can continue to change the schema. And it's as easy as just saving a record that represents a new type of object. So for instance, if you were building like a to-do list app, which is the example I'll use throughout the presentation, and you want to have to-dos that have a title and an is-completed flag, you can just create a record which has type to-dos with a title and a completed flag and save it, and that will create that record type in CloudKit. That's just in development. When you go to publish your app, you move it into production and it becomes static, and then each time you update your app, you can move any changes into production, and there's a migration process. So it supports the Apple ecosystem. It has native frameworks for iOS, macOS, watchOS, tvOS, a web framework called CloudKit.js, which is equivalent to these for building front-end web apps, a RESTful API for interacting with the public data. I'll talk about in a moment what I mean by public data versus other data. It has a built-in user system with automatic authentication. By that I mean every CloudKit instance has a built-in users table. That's a record type that exists no matter what, and it uses iCloud for authentication. That means that if there's an iCloud user authenticated on the device when your app launches for the first time, then a user gets created for that iCloud user in your users table without you having to do anything else. So there's no authentication flow or account creation required. Click this link in your email to confirm the account. None of the stuff you would normally have to build. It just happens automatically. The flip side of that is that the user can disappear at any time because you're not in control of whether they're authenticated or not. So your app, especially if it runs in the background, which it likely does for CloudKit to get data updates, it could close your app, go to settings, and log out right in the middle of an operation, and you have to be able to handle that case. That turns out to not be all that hard, but it's something that you might not be used to dealing with. And finally, largely free. So pricing is usage-based on how much you're storing in the database, how many assets you're storing, and how much data you're transferring between devices in the cloud. Each account is given quite generous quotas per month, and those quotas grow as your user base grows. So each time you get a new user, you get a little bit more quota. Users' private data, and again, I'll talk about public versus private in a moment, how you distinguish that, but their private data doesn't count towards your storage, it counts towards their iCloud storage. So especially if you're building an app that has large assets or things like that, that can be great because you can build a really rich app that stores a ton of stuff and you're not having to pay for that storage. You're only charged for usage over the quota, not surprisingly. You're billed every month. And so they basically take the quota you have, your base quota plus your user's extra quota, marginal quota, subtract what you've used, and if there's anything left over, then you're charged a few cents per gigabyte for each of those, across each of those three categories. They have an estimator on their website. This is just a URL that's easier to remember. But if you go to developer.apple.com/iCloud, there's a whole page on iCloud in general, a bunch of stuff on CloudKit, including this estimator. It's pretty basic. You just slide to how many users you think you're going to have, and they show you how much data you could use with that many users before paying. But it pretty quickly goes close to petabytes. So I think for many people, it would be free, especially if you're not storing any public data, which is also quite common. Okay, so very quickly, review. What is CloudKit? It's an Apple product. They use it, so they're going to keep supporting it. It's a database as a service with a just-in-time schema, which means it's easy to get started, but powerful and flexible. And it replaces the need for a server for a whole class of apps. If all you're doing with your server is storing and moving data around, you can use CloudKit instead. Supports the Apple ecosystem, front-end web, and an API. That really makes it, in my opinion, at least the best database as a service for Cocoa developers, because the API, I think, is really nice. Has a built-in user system with automatic authentication, which means you never have to write social sign-in code again, which I think we all know, if you've ever done it, is a giant pile of pain. And it's largely free, which means that most apps aren't going to have to pay to use it. Okay, so that's what CloudKit is and why you might want to use it. Let's talk about sort of how things are structured. So we're going to talk about CloudKit's different supported object types, the different kinds of things you can store in it, how it stores your data and sort of where it stores it, how you can define your schema in a little bit more detail than we said before. So we'll start with CloudKit supported object types. So there's three types of objects that you can store. Records, which are instances of CK record, assets, instances of CK asset, references, instances of CK reference. So I'll talk about each of those in a little bit more detail. Records, like I said, they're CK records. They have a whole bunch of properties, of course. The ones that really matter for this kind of intro talk are record type. That's a required property. It's a string that is the type of thing that you are representing with this record. So again, the to-do list application example, if you're trying to save a to-do, its record type would be to-dos. So it follows the convention. You can set your own convention if you want, but I would recommend you follow theirs, which is the same thing that most databases use, which is that the name of the table is plural, And if you have like an ORM, so you're creating instances that are mapped to rows, obviously the name of that class is singular. So for to-do, the table is to-dos. So it has a record type. It also has a record ID, which is just its unique identifier. You can provide one if you want. You can actually specify a string, which effectively, the CK record ID has a little bit of extra stuff, but effectively you initialize it with a string. If you want to manage your own IDs, I don't really see a good reason to do that if you're using CloudKit. So you can provide this in the initializer, or there's an initializer that just has record type, in which case CloudKit creates a global unique ID automatically. And then you set your properties. It basically supports key value coding, so where string is the key and the value is instances of classes that conform to this protocol, which is an Objective-C protocol, CK record value. This turns out to be a bit of a pain in the ass on Swift because this was all written in Objective-C, which means that the only things you can save are instances of a whitelist of classes, which are all Objective-C classes. So for instance, you can't save strings, you have to save NS strings. You can't save dates, you have to save NS dates. You can't save booleans, integers, floating point numbers, you have to save NS numbers, etc. Spoiler alert, with my library, you don't have to do that. So this would be an example. So if you have a record, you can set its title like that. You provide the key title and a string, take out the garbage if that's your to-do, and the due date would be a date that's an hour from now. So that's records. Next is assets. So assets are instances of CK asset. They represent a file, and they're very simple. They basically just initialize them with a file URL, which points to wherever that file is. And then you associate that asset with the record. And then whenever you save the record, the asset gets uploaded along with it. And then later, if you pull the record down, the asset comes back down with it. So they can't be saved directly. They have to be a property on a record in order to be saved. There's no way to just upload an asset by itself. And in case you're curious, there is a periodic process that CloudKit does to see if there are any assets that aren't related to records, and it deletes those. But they don't make any guarantees about how often it happens. So if you were saving enormous assets in your public database or your user's private database, if you want to be a good developer citizen, you need to be aware that those assets could stick around for a while. So you should be cognizant of that before you build like a share 3-hour movies with your friends app. That's assets. And then last but not least, references. And since it's a CK reference, they take a record, which is a CK record, and that's the destination of the reference. And then they take a reference action, which is basically what should happen when that related record is deleted. So, for instance, with the to-do list to-do example, a to-do would have a property to-do list, which is a reference to its parent to-do list. And its reference action would be delete self, which means that when my to-do list is deleted, I also want to be deleted. To me, that was a little bit, you might be used to going the other way around with your relationships, one to many instead of many to one. Everything is many to one. Which turns out to be a better idea, actually. So that's references, and again, just like, so whether deleting the origin deletes the destination is the reference action. Just like with assets, they cannot be saved directly, so they must be a property on an origin record, so to do in this case, to be saved. So that's the supported object types. How does CloudKit store its data? Well, just like it has 3 types of objects you can store, it has 3 types of data storage. Containers, databases, and record zones. So containers, they're the outermost layer of storage. Typically, there's 1 per app, so a 1-to-1 mapping. You can actually configure it to not be that way, but that is a pretty rare case. So we can talk about that at the end, but you can assume from the rest of this talk that there's a 1-to-1 relationship. Every app has 1 container. Every container has 1 application. That's where your schema is defined, the different object types you have and the properties that they have. This is an example in Xcode. This is what it looks like when you set up your container. You notice that by default it says use default container. There's only 1, but you can have more than 1. So that's the container. Inside the container is a database. There are 3 types of database in every container: public, private, and shared. Every container has exactly 1 public database, and then n private and n shared databases, where n is the number of users in that user table. Said another way, every user has their own private and shared database, and then everyone shares 1 public database. So that is a diagram. This is a little bit out of date. So You would have a shared database here as well for each of these people, but that's roughly what it looks like.
And don't sue.
Don't sue me. Right. So public databases, like I said, there's one per container. If you guys are familiar with the acronym CRUD, create, read, update, and delete, kinds of things you can do with records. Every user can read every record in the public database, even users that aren't logged into iCloud, that don't have their own user record. Every authenticated user can do everything, create, read, update, and delete any record, even records that they did not create. So that's something that might not be immediately intuitive. And obviously, you can, with logic in your own app, kind of tamp that down a little bit if you wanted to, but by default, that's what CloudKit allows. The data in here counts against your iCloud quota, your storage quota. And this data, the public data, is what's accessible via the CloudKit API. So earlier when I said you can access public data over the API, I mean data in the public database. However, because there is the potential for lots of, that's fine. Because there's potential for lots of simultaneous writes, because everyone can edit every record and you can have millions of users, you can't do atomic writes and you don't get granular change notifications. So you can be notified when stuff changes, but you can't get CloudKit to tell me exactly what changed in this database since this point in time in the past. So for that reason, it can be kind of a pain to work with. Private databases. As I said, there's one per user. Each authenticated user can have full control over their own records. No one else, not even the dev, has any access to these records. So CloudKit, in the CloudKit dashboard, you can see some basic statistics, some things like, I don't even remember what they are, but roughly, on average, how many records does a user have in their private database, things like that. But you can't get any statistics on an individual user's private database, and you definitely can't see the records inside anyone's database. The data in here counts against the user's iCloud quota since they're the only ones that can see it and use it. And here, because simultaneous writes are unlikely, they're possible if you have like 10 iPhones and you're being crazy with your to-do list, but it's pretty unlikely. It's actually, with sharing, as I'll explain later, it is possible in some sharing cases as well, but the number of simultaneous writes is going to be much lower. Because of that, atomic writes and change notifications are supported with an asterisk, which is that if you follow some best practices that are not made clear at all, at least in my opinion, and I had to sort of figure out through trial and error. Okay, finally, shared databases. They're like private databases with the following differences. So rather than containing records that you created, they contain records that others shared with you. So for instance, if my wife and I are going to go grocery shopping, I have my to-do list app, I create a grocery list, that's saved in my private database. I wanted her to be able to see that and us to be able to collaborate on it, so I share it with her. She accepts the share. We won't get into how sharing works because it's pretty complicated, but suffice it to say, when she accepts that, that same set of records shows up in her shared database. So it's in my private database, it's in her shared database. Because of this is not immediately obvious, but you can't create kind of free-floating records. So for instance, my wife, the grocery list is shared to her. She can edit those existing items. She can add an item to that to-do list, right? So she can add an item that has a parent, which is a to-do list. She can delete the to-dos and maybe even the to-do list. But what she can't do is create a new free-floating to-do list in her shared database. She creates it in her private database and would share it. I would see it in my shared database. Okay, so as you might imagine, that means that this is actually just kind of a mirror. The shared database actually is just a little view into my database, right? So in reality, there's only one copy of the records. Because of this, the data only counts against the person who originally shared it, because there's only actually one copy and it's in their database. And similarly, just like before, all the stuff about atomic writes and reads are possible if you follow best practices, which are a little bit obscure. Okay. Finally, so we have containers, we have the three types of databases in each container, and then in each database we have record zones. They're the innermost layer of storage. They exist inside databases. They're a way to logically group and work with records. This is what Apple tells you, and they basically leave it at that. It turns out these are very important, but they don't make it very clear. And even, like, you can watch their talks, and they just kind of just assume that you know how to use them. Maybe I'm just dumb. I don't know. Every database type has a default record zone. So every database ever has one record zone in it to start with. Private and shared databases can support custom zones, meaning you can create your own record zones and add them to those databases. You can't do that in the public database. Finally, you must use custom record zones to share records with others and to get atomic writes and change notifications. So back before when I said if you follow this best practices, that is, you create custom record zones when you need to. I'll get into when you need to here. So this is sort of a review and sort of putting all the pieces together for you to get this picture that's never quite made clear in my mind from Apple. So every reference and asset, right, you can't just upload them by themselves. So they have an associated record. Every record lives in exactly one record zone. You can't move a record between record zones. Every record zone lives in exactly one database. Every database lives in exactly one container. Related records have to share, just like references and assets are connected to a record. Related records that are connected to a record, all of them have to share a record zone. So you can't make a reference across a record zone, and because of these other rules, that means you can't make a reference across a database or across a container. So in summary, here's a chart of all of the things I just said. So basically, public database, everyone can see it. You, the developer, are tasked with the quota for it since everyone can see it. There's no atomic writes or reads, no granular change notifications, no custom record zones. But you can store root records, that is records that don't have any parents in there, all you want. Private database and shared database, both of those, only the user can access their own. In the case of the private, the user is the one whose quota is affected. In the case of the shared, because it's just a mirror of someone else's private data, it's the other person's private data. Both of them support atomicity, granular notifications, and custom record zones. And in order to get atomicity and notifications, you have to use custom record zones. Finally, root records. The private database allows you to create root records. You can create your own to-do lists, but as I mentioned before, the shared database does not. So, did everyone fully capture all of that ridiculously complicated, almost the same but not identical information?
What's the use of record zones?
So, the use of record zones, and I think, no, okay, so I might cover it again later. We'll skip over it so. But the point of record zones is that you can get notifications whenever a record zone changes at all, when one is created, and when it's deleted, or when its contents change in any way. And then you get, the first time, there's basically a call that says, give me all the changes in this record zone. First time you ever do that, it's going to give you the full, it's going to give you the full history of those changes, right? And then it's going to give you a little token that tells you where you are in history. And you hang on to that. The next time, you pass that token, and it just gives you what's changed since then. You can combine that with the fact that you can be notified about these changes and put those two together so that as soon as anything changes, you're told that this exact thing changed, and you can get only exactly what changed. So you can very efficiently stay up to date in an automated way. But in order to do that, you have to use custom. That stuff doesn't work for the default record zones. So you have to use custom record zones, and then there's all these rules about custom record zones that you have to follow. So as I'll go through in a minute, we can kind of put all that together into a simple set of rules, but it's a little hard to grok at first. Okay, so that's how CloudKit stores data. Finally, defining your schema. This is pretty quick. Again, a schema is just the types of objects that you're storing and the properties and relationships they have. So for example, a to-do would have a title, string, file your taxes, an is completed flag as to whether you completed that or not, which would be false for me. Due date, which is actually the 18th. I looked this up for this slide. It's not the 15th. Parent to-do list, like financial tasks, whatever your to-do list is called. And then, that would actually be a reference to a to-do list. And then an attached file, which would be an asset, your W-2 form so that you can properly file your taxes. So that's what a schema is. You can create that in the dashboard or in code. Here's what the dashboard looks like. So, if you hit record types and you have all your types of records, you can see there's a users type, which was created automatically, and I've created these two types. Well, I've actually just created this type, and now I'm editing this one. I mean, it's pretty straightforward. You put in the name all the different properties, and tell them what kind of property it is. And then there's some indexing you can turn on and off so that you can find things more efficiently. You can also do it in code. So you would create the record in code, you would populate it with the fields and values of your object type, and you would save it to CloudKit. That looks roughly like this. So you have a to-do, its record type is to-dos, it has a title, take out the garbage, is completed, false, due date in 1 hour, and then you would save it. And save code is how it's kind of the next topic, which is interacting with CloudKit in code. So we'll leave this here and review where we are, and then we'll move on to that. So 3 object types: records, which are like rows in a DB, Assets, which are like files, and they have to be related to a record in order to be saved. References, which are like relationships, they also must be related to a record in order to be saved. You have 3 data storage types: container, database, and record zone. Apps typically have one container, where the schema is defined. So one of the other things that is not said explicitly, but is true, and that you might be confused by, is that there's these things called databases, and most people are used to databases being where you define a schema. So if you had an app with 3 databases, you would think you could have 3 different schemas. That's not the case. Your container has the schema. All the databases in that container share the same schema. Each container has 3 types of database, as I said: public, private, and shared. 1 public, and then 1 private and 1 shared per user. Database type determines visibility of the data and whose quota is used. And then each database has 1 or more record zones, and record zones determine the atomicity and shareability of the data. So in order to have atomic saves and granular notifications, in order to share data, that data has to be in a custom record zone. Okay. Anyone have any questions at this point, or are you just totally confused? Yes?
I just have a quick one. For the automatically created schema where you just save a record, is that just an additive thing? Like if I have attachments and I change the name of that later to I don't know, files, is attachments still going to be my schema?
Yeah, so it is additive. So you can change it, you could add properties over time, but if you try to change the name of the property, I can 99% sure that it would just create a new property. Yeah, new property.
That's something you should maybe do during development, not after it's in production, right?
Yeah, well, it freezes in production. So you'll get, if you try to submit something that doesn't match the current schema in production, you'll get a CloudKit error at runtime that says as much. But because all this stuff is also defined with strings that you're manually typing in, it is quite possible to end up with a to-dos table and a to-do table, and half your data is in one and half your data is in. So, which is another thing that my library, I actually had that exact problem. Which is another thing my library tries to solve. There's a whole bunch of stuff that usually in most cases would be compile time and is runtime, maybe not runtime until you're in production, which is not what you want to find out. Okay, so that was CloudKit's architecture, explained at a high rate of speed. So here's how to use CloudKit in your project. So we'll talk about several things here: setting up your project to use CloudKit, creating objects, saving objects, fetching objects whose IDs you already know. So if you have some objects in memory and you want to get the freshest version of them. Querying for objects matching criteria. So for instance, if you wanted to get all the users' to-dos that aren't completed yet, even ones you might not have locally, you could do a query for that. Fetching only what has changed, which is what we've now alluded to a couple of times with these change notifications, the other side of the change notification. And then getting notified when changes occur. So you can get notified, these are actually the other way around, getting notified when changes occur, and then fetching only what's changed. Okay, so start with setting up your project. So you can see the quick start to do this if you want to, which is also at developer.apple.com/iCloud, but this is another short link that takes you right there. The gist, though, is, first of all, make sure you have Xcode, you have basically everything you would need to make and publish an app. If you have that, then the steps are pretty simple. Within your project, I'll show you a screenshot of this in just a second, but within your project, you would select your project file from the left-hand navigation pane. You'd select the capabilities pane or whatever from across the top there. Under capabilities, you'd flip a switch to turn on iCloud. Under services in that section, you'd check CloudKit. And then last but not least, under containers, you'd set the default container, which looks like this. So if you've already selected your project, then you get this screen right in your main editing area. Go to capabilities, turn on iCloud, check CloudKit, and this will appear, and you'll just leave it as use default container unless you wanted to do crazy container stuff, which we can talk about at the end. Okay, so that's pretty straightforward. Then you're set up to use CloudKit. Oh, and one more thing. You notice there's a button here that says CloudKit Dashboard. So you can click that, and it will take you, obviously, straight to your dashboard. You can also get there from developer.apple.com/iCloud. Okay, that's setting up your project. So creating objects, we kind of gave you a preview of this a minute ago, but here's kind of the example that we'll go through. So we're creating a grocery list in our to-do list app. Because we want to be able to get notifications about that and share it, it needs to have its own record zone. So first we're going to create a parent custom record zone that will contain it. Then we're going to create the to-do list itself, which will be a grocery list. Then we're going to create some to-dos, eggs, milk, and bread. These are the things we want to buy at the grocery store. Right, that's it. So first we'll create the parent record zone. Pretty simple. You just create a CK record zone and provide it a custom zone name. For whatever reason, even though with CK records you can just omit an identifier and it will create one, that is not the case with record zones. So you can pick one that makes sense to you. You don't actually really use this very much, in fact, at all after you create it. It just has to have a unique identifier. So in my code, I just use it globally. I just use UUID in this UUID to create one, but you could give it a reasonable name like that if you wanted to. Once we've created that, you'll create a to-do list. So here we have grocery list, which is a CK record, has a type to-do list, and now we're using this other initializer where you provide a zone ID. That's the zone we just created because that's where we want to save this to-do list. Then we give it a title and say it's not archived yet. That's something that if you wanted, when you were done with your to-do list, you could archive it. Then we'll create some to-dos. These are all three the same. They're just three different things in our list, so I'll just talk about the first one. So we have a record type, which is to-dos. Zone ID, the same exact thing as before. It's a to-dos type instead of a to-do lists type. It's in the same zone. It has a title, a completed flag, and we relate it to its parent to-do list. So here's the CK reference to our grocery list, and we say delete self, which means that when that grocery list gets deleted, this to-do will also be deleted. You can also set this as none, in which case this to-do would stick around even if the parent to-do list got deleted. And then these two are the exact same thing, just two more to-dos. Okay, so that is the code about how you would create objects. Now that we've created them, how do we actually save them to CloudKit? So saving our grocery list, we're going to create a saving operation for the record zone. We're going to create a save operation for the records. We're going to make them dependent on each other. I'll go through all these in more detail in a second. And then we're going to add those operations to the database's operations queue. So this gets to kind of the core way that CloudKit communication works. Because CloudKit is fundamentally an internet, you know what I'm trying to say. Uses the network. I don't know what happened there.
Series of tubes.
Yeah, it's a series. It's basically just tubes. That's all I really know. Because it uses the network, obviously it can get interrupted. It can have long delays. It needs to be asynchronous, right? That's what I'm getting at. Because of that, everything that you do regarding pulling data down, communicating with CloudKit in any way is done with an operation. Specifically, you do it with one of a bunch of different subclasses of CK operation, which is itself a subclass of NS operation. So you generally create one and specify, all of them are of the form CK, take an action on a thing operation. For instance, CK modify records operation, or CK fetch record zones operation. And you would provide the thing you need. So if you're modifying records, the records you want to modify. If you're fetching records, the IDs of the records you want to fetch. Right? So you create that. Then there's some callbacks, which are, here are the records you wanted. Okay, now I'm done. And then you would add that operation to the database where you wanted it to be performed. And then at some point, hopefully soon, it will be performed. And at the end, we can go through like operation quality of service for operations and how to figure out when your operation is going to execute, long-running operations, stuff like that. We can talk about that at the end. So let's talk about creating our record zone save operations. So as I said, we want to modify record zones. So it's a CK modify record zones operation. We provide the record zones we want to save, which is an array. In this case, you only have one, that grocery list record zone. And then you can also do records you want to delete at the same time with this operation. We don't have any, so that's new. And then it just has one callback, one closure block, which is modify record zones completion block. So whenever it's done, it's going to call this, and it's going to give you the record zones it's saved, the records of the IDs, the record zones it's deleted, and an error if there was one. Your error handling should be robust, unlike mine. And because these errors are very common. If it is not exactly perfect, the conditions are not perfect, you're going to get an error. If the network's bad, if there's no connection, if the zone is busy, if you didn't format it quite right, on and on and on and on. It's going to happen all the time. So you need to be ready to handle that. That also is one of the biggest motivations for me making a library. But anyway, hopefully nothing went wrong this time. And if that's the case, then we're just printing out that we saved these record zones. Notice, though, that we haven't actually added this operation to any operation queue. So nothing's happening yet. This is just how you would set up that operation to save it. We'll do the same for records. It's almost identical. Here are the records, our grocery list, and the 3 different items we want to buy in an array. This, instead of being a modified record zones operation, it's a modified records operation. Same concept though. You have records you want to save, IDs of records you want to delete, and then a completion block which passes the same things in. And again, we hope there's no error, and we say that we save these records. Okay, now, because these records are in a custom record zone, if that custom record zone is not ever saved, then the records will not be able to be saved, right? So you could just run both of these into your private database if you wanted to. But if the first one fails, you know the second one's going to fail. So basically, you're just wasting bandwidth, wasting time, and having more code to have to handle more errors. So the smarter move is to make these operations dependent and say, don't even do this records operation until my record zone operation completes successfully. So that's what I mean here. Make records operation dependent on record zone operation. That's simple. It's just a one-liner. Save records operation dot add dependency. Save record zones operation. If the record zone, if any of these operations come back and give you an error, they will not actually. Don't quote me on this. I'm 99% confident they actually get marked as canceled, not completed. And because of that, you can do things like this. And there's situations we won't get into in this discussion, but if you have a really complex model, there's times when you have like 8 or 9 or 10 of these operations. And the smart thing to do to keep from doing these big blocks of code, you end up with like, when this one completes, then this completion block fire this one, right? To do them all in a line and then all dependent on each other in the right way, and then put them all into the database's operation queue at the end. So that's why I mentioned this, even though it's not that important in this case. Finally, we'll add them to the operation queue. I neglected in this slide to show you how to get the private database, but it's pretty simple. There's a CK container has a class function default, which gives you the default container, and that default container, just like every container, has a public, private, and shared database for the current user. So that's how you get that, and then you just add these operations. Okay, anybody have any questions or deep thoughts about that before I keep going? It wasn't until I started saying this out loud that I realized how mind-bending it actually is. I've been doing it for like 4 months, so it makes sense to me now. Okay, so fetching objects whose IDs you know. So now we've created those to-dos, that to-do list, we've saved them, it's been a while, we want to make sure we have the freshest versions. How do we do that? Well, assuming that records to save is that array we created earlier, which is the records, those 4 records, the grocery list and the 3 items we want to buy, we need to just get their IDs. So all we do here is we just map records to save and pull out all the record IDs. So now we just have an array of record IDs. And now we want to fetch records. So we use a CK fetch records operation, and it makes you provide the record IDs you want to fetch. Again, there's a completion block, pretty much the same thing. This time you get a dictionary, which is the record ID and the record, key value, and then an error if something went wrong. This can be nil if there are no records. So make sure nothing's wrong, make sure there were records. Because it's a dictionary of keys and records, pull the records out, and then print the records. That's all I've done here. And then, of course, don't forget, because it's an operation, you have to add it to the operation queue. So that's fetching objects. Querying for objects, matching criteria. So again, what if we wanted to know all of the incomplete to-dos, regardless of what we already have? You start by creating a predicate that describes what you want, and then here I put it into this custom function. I wonder why I've done that. You'll see that. So you put in the predicate, and then you get the records that we found, and I just print them out. Why did I create a custom function, though? I did that because there's recursion involved with using this operation. So here's that function. It has another function inside of it, which is very similar, and all we do in the outer function is just call the inner function, passing in that completion block. Okay, so what does the inner function do? The inner function is more complicated, but basically, in order to do a query, you need a predicate, the type of thing you're searching for, to-dos, to-do lists, etc. The predicate and type go into this query. CK query has a type and a predicate. And then the query goes into a CK query operation. In fact, let me jump ahead and I'll jump back to this. Look at that fancy animation. Okay, so you create a predicate that describes what you want. You create a query, which is the type of records you want to look for, plus that predicate. You create an operation that contains that query, so it's a query operation. When you execute that operation, it has callbacks that each time it finds a record that matches, it's going to fire a callback that says, I found this record. You're going to want to gather those into an array. So each time it's called, you add a record to this existing array. And then periodically it's going to say, I'm done for now, because basically in the background, I've gotten an HTTP response and I've given you everything about it, but that might not be all the records. I have to go do another response. If that's the case, you're going to get this object called a query cursor, which basically is a thing you use to call the same operation again and say, okay, I want more records, but start from here. It's basically just pagination, right? So you're going to call that over and over and over, and eventually you're not going to get a query cursor, which means that's it, that's the end. And at that point, you're going to return this array that you've been recursively feeding into itself and adding records to, and that'll be your full set of records. In case you're curious, yes, there's lots of ways that you can limit what you get back, that you can say only want certain properties. You can do all sorts of really sophisticated things with this that I'm skipping over. But this is if you just want everything, which is a pretty common case. So to go back, in fact, we can go back this code at the end if you really want to. That's the gist of it. It's pretty complicated, so we'll skip over. And then fetching only what's changed. Okay, so this turns out to be very important. There's two types of change sets. You can get change sets for a database, and you can get change sets for a record zone. They have unsurprising operations. CK-fetch database changes operation, or CK-fetch record zone changes operation. Each one provides change sets for the thing it contains. So the database changes operation tells you about the record zones inside that database that have changed. A record zone changes operation tells you about the records inside that record zone that have changed. So what you do is you put these two together to get the full set of changes within a database. What I just said. Database deleted and modified record zones. A record zone operation gives you deleted and modified records. Each one provides changes since a time in the past. So if it's the first time calling it, this is what I was talking about earlier. If it's the first time you ever call it, then it's going to give you the full history of changes. Each subsequent time, assuming you give it this identifier it's given you previously, it's going to give you the changes since that identifier's representing time. So at the end of the call, it gives you what's called a server change token. That's an opaque ID, which represents where you are in history. You need to pass this in the next time you call this method to get the changes since then. Okay, so this is where another big shortcoming of CloudKit starts to show up, which is that CloudKit has no local persistence. So if you wanted to implement using this the way that they want you to, which is do all these custom record zones that I already talked about and process all these changes, you need to be able to save these different server change tokens, one per database, and then for the private and shared, one per record zone, right? So you need to be able to save those somewhere, fetch them, update them, etc. You need to be able to save record zones and save records somehow and be able to create them, delete them, update them. So this is a list. You obviously could make your own. This is not like some protocol, but you would need functions that did these things, which is get a change token for a database. So there's an enum, CK database scope, which is public, private, or shared, which is an easy way to reference the database you're talking about that they use throughout the API. So change token for a particular database, set the change token for that database, same thing for a record zone, and then some method to delete a record zone and save a record zone, and to delete a record and save a record. You would need some way to do that combined with this code. So if you had that, what might that look like? So this is if you wanted to get all the changes in a database. You would start out by getting the change token from wherever you're keeping it, if you have one. You would set up this set of record zone IDs of deleted record zones and IDs of changed record zones, which this operation is going to populate. You create your CK fetch database changes operation and pass that token in, which first time ever is going to be nil, right? And subsequently is not going to be nil. And then every time a record zone with an ID, they find a deleted record zone, this callback is going to be called record zone with ID was deleted block. And you're going to insert that record into your set. Same thing for a changed block. You're going to update it here. That's going to happen a bunch of times, and eventually you're going to get fetch database changes completion block, which is similar to others. It has the new server change token that you want to save, a deprecated property that they're still sending in called more coming, which you can ignore, and then an error, which is if something went wrong. So we check for the error, we set the new change token, and then we go and process these, right? So for each of these deleted record zones, we want to delete that record zone altogether. But for the changed record zones, we want to go fetch all we know is that the record zone changed. We don't know what changed in that record zone object, and we don't know what records inside that record zone have changed. So we want to go fetch that information. So we use this custom method, fetch changes for record zones. Oh, yeah, we have to add the operation, don't forget. And then fetch changes for record zones is very similar, so I'm going to skip over it for the most part. But basically, instead of passing in the database, you pass in those record zones that you want to know about. And this is a way to pass in your server change tokens for each record zone. And then same thing's going to happen. Every time a record is deleted, it's going to tell you. Every time a record was changed, it's going to tell you. And then when it's done, it's going to give you a new change token for the next time. And so by doing that, when you get a record change, you're going to get an exact set of changes. You're going to get that. When the record was changed, you're going to get the new record fully. When a record was deleted, you're going to get its ID so you can delete it. And by doing those two things together, you can get the exact state since the last time you asked. Does all that make sense? Okay, so that's fetching only what's changed. Now you can call those, of course, whenever you want, but if you're calling, if you do that, then a lot of times there's not going to be any data. So ideally, wouldn't it be great if you could only call them when you knew there was more data? Well, it turns out you can. There's these things called subscriptions, which will only fire when changes occur. So we'll look at that very briefly. Yeah, so it sends a push notification. That's how it works. These are data-only pushes. That means that no user permission is required. There's no dialog shown or anything like that. We won't get into the details of how to mix and match those really today, but you can use them with traditional push. But if you don't have traditional push, then the user never knows they don't have a dialog. Whoops. Something I'm supposed to fill in there. So when you get the notification, you basically inspect it to see if it's a CloudKit notification or another kind of notification. And then if it's a CloudKit notification, you do what you need to do. Otherwise, you hand it off to your code that deals with notifications. But push, of course, is not guaranteed, and the payload for push is very small. So sometimes push cannot tell you everything you need to know. So there's also a parallel API, which has its own set of operations that I won't go into, that basically you're supposed to check. So whenever you get a notification, you go and check that API and get the full version of that object, which could be the same as what you have or maybe not. Then you process that notification to, it basically tells you that this database has changed, so you go and update that database. Then you mark that notification as read with the API, so you never get it again. I've skipped over some of that here. I feel us glazing over, so I think I'm going to skip over this. It's pretty equivalent. There's a few things you have to do. I'll do that at the high level. You have to create a subscription for your database, so your private and shared databases. That tells CloudKit that you want to know when stuff changes. So that's all this code does. It's very equivalent to code we've seen before. And then in your typical where I receive my push notifications, application did receive remote notification fetch completion handler. You try to handle that notification. So I've written code that basically you pass it in here. This code sees if it's a CloudKit notification, and if so, it handles it. Otherwise, it throws an error. So that way, you can just catch that and do your normal notification handling. And this function just basically makes sure that it does a bunch of code to make sure it's really a CloudKit notification, and then it looks at its notification type. So you can get all sorts of notifications. You can get a notification that is one you've already read. I have no idea why they would send you a notification that you've already read, but that is a type. You can get one for record zones, which is very confusingly now deprecated, so you'll never actually get them in theory, but they don't tell you that. You can get one for queries, which is, so just like with a database notification, you can say that query we talked about earlier, you can say anytime this query changes, the results of this query change, I want to know about that. I'm not supporting that here. And then the last category is a database notification, which is what we're expecting. You didn't see previously, but those, when you create a subscription, you have to give it an ID. That's just a string. So I just have the practice of your private database subscription gets private, and your shared one gets shared. And so then we'll go and fetch database changes, that code we just talked about, for those databases. So for the private database, we'll fetch those changes and we'll get the record zones that change. We'll then turn around, fetch the record zone changes, and then we'll have exactly what's changed since the last time. So that is like the full soup to nuts way to stay updated. But as you can tell, it's a ton of boilerplate code, and it's basically identical for every single app in the world. So that gets us to CloudKit shortcomings. So no local persistence. So where am I on time? Am I over?
Just a little bit.
Just a little bit. Okay. Well, this will be fast. Now that everyone is totally.
If anybody needs to step out, this might be a good time to do so. But
Yeah.
otherwise, continue.
Yeah, please do. Okay, I'll make it fast. So as I talked about, no local persistence. There's no compile enforcement of the schema, right? So you might have a to-do that has a title, but there's nothing to prevent you from trying to give it a tile instead of a title. Getting related objects requires an additional fetch. Because those objects, you have a to-do list which has records, it has a bunch of references, so you have to go fetch the to-do, and then you have to look at its references, get all the IDs, then fetch again, fetch again, fetch again. So if you have a big tree, you might end up doing tons of network requests for what ends up being, like one object and then two objects and then four objects, when you could just do one request. The best practices, as I've kind of shown, are not very well documented, but it's important to follow them if you want to get the best results. There's no synchronization per se. We kind of talked about a way to do a version of push synchronization, or push synchronization. Getting stuff from the server, sending stuff to the server is kind of a manual process as well. And lots of runtime errors, which I've barely touched on, but it's a big problem. Let's see, I've kind of talked about that. I'll do this high level. This is why you want local persistence. I think you guys all know that. So there's a couple of different options, and I tried all these. The last one, tightly integrating with existing persistence solution, which is what I'm doing. Best option, but very time intensive. Trust me on that. Basically the only way to efficiently be able to do stuff like if you want to search the objects that you already have, you need to be serializing them with some kind of ORM instead of just like serializing the whole record, because then you have to pull all your records in the memory to search them. So I went with this option, and we can talk about that if we haven't all died of boredom. I think you guys. I cut this down at the end. So you guys know what I mean by this. I've kind of already gone through these. Let's see. So I'll quickly touch on the runtime errors. So there's errors that should be compile enforcements, which I've kind of already touched on. Schema violations, relationships to break rules. So if you create a relationship across a zone, you're going to get an error about that, but you shouldn't be doing that in the first place. Errors that have a sane default resolution. For instance, record zones can be busy because because the writes are atomic. You'll get if multiple people are trying to write, you'll get an error and it says please try again in 2 seconds. Obviously, what you should do is try again in 2 seconds, but you're the one that has to handle that. There's errors that are avoidable by following best practices. Things like permission failures, so trying to write records when you don't have a user. You can check and see if you have a user and not write if you don't. So CloudKit is intended to solve all those problems. I will give you the very high version, and to be honest, it is a work in progress that I would love your help on to make it a little bit more mature than it is in the moment. But I'll talk about how I solve these problems at a very high level. So it has inherent local persistence. It has typed records with real Swift properties that work the way you would expect them to. Because of that, a compile time enforces most of CloudKit's rules, has direct record-to-record relationships, so you're not having to do these multiple fetches, has automatic synchronization. And because it has inherent local persistence, because it has inherent local persistence, I'm going to skip the rest of the slides because they get too long in detail. But, several of the next ones. Because it has local persistence, everything you do is against a local cache. So, as we talked about before, in CloudKit, one public DB and each user has their own private and shared. So Mist has a local cache which just has a public, private, and shared DBs. Every time you do a find or a fetch or whatever, you're just doing it against that local cache. Every time you do a write, you're just doing it against that local cache, so it's fast. And then Mist detects when you do a write, pushes stuff up to Mist, pushes stuff to CloudKit, and then uses all that code we just went through about synchronization to ensure that whenever something changes on CloudKit, it gets updated in your local cache. And because of that, you can safely do your queries on your local cache. So they're synchronous instead of asynchronous. I don't think I mentioned that. And they're super fast. I'm going to jump out of this and see where to pick up here. So kind of a very high-level example of what this looks like. So if you want to create a to-do list, this is how you would do it. There's an abstract class record in Mist, so all of your classes are just subclasses of that. It is backed. These might look a little familiar if you've ever used Realm. I'm just using Realm. I can get into the details of how that works if you're interested. But you just follow the same rules you would follow with creating a class in Realm, which is pretty straightforward. You need this because I don't know what different properties you have. There's no way to introspect that, unfortunately. Maybe there is in Swift, and I'm not enough of a Swift magician. If someone knows, I'd be interested. But this is so that when we go to turn this into a CloudKit record, we know how to find this stuff. So there's property keys, relationship keys, because we need to turn those into references and vice versa, and asset keys because we need to turn those into assets and vice versa. And then your to-do, same thing, and it has a to-do list. This is just convenience. It's a computed property, which is parent. Parent is an inherent property in the record because it's actually an inherent property in the secret record. I didn't talk about that. So that's how you would, oh yeah, there's the same thing. Property keys and relationship keys, just like I talked about. So you could then create them. This is equivalent to what we said before, but you can see it's much simpler. This is kind of some of the magic here. All that stuff we talked about with custom record zones and where things go and having a parent, not having a parent. When you put all that stuff together, it turns out that by knowing where you're storing it, the database you're storing it in, which you always have to tell MIST because it needs to know what cache to put it in, and by knowing whether it has a parent or not, you can know what record zone it needs to be in, right? Because public DB only has one record zone, so they're all going in there. Private DB, if it has a parent, you need to put it in a parent's record zone. If it doesn't have a parent, you just create a new record zone. So because of that, record has two acceptable initializers. One is database scope, where you define a database where you can store it, and the other is parent, where you define a parent record, which is its parent. And as a result, you get the best practices automatically. You never have any of the errors about breaking rules about relationships, some other stuff. You can try if you want to with CloudKit. You can like take a record that's in the public DB and try to force to save it in the private DB, which will obviously create an error. None of those errors will ever happen. So it's pretty straightforward. How do you save them to MIST? If you've ever seen Realm, this looks very familiar. MIST.write instead of Realm.write. So in reality, there are 3 realms, 1 per database. But because you defined the place where you want to store that record when you created it at initialization time, we can figure it out inside this block. So inside MIST.write, you just create a set of all the records you created, MIST.add. So that adds into local DB. We use realms change notifications to find that out. We create all the CloudKit BS and we send it up to the cloud. So there is a callback, which is basically just like there are data callbacks that you can use in Realm. We have equivalents to those. So you can get local data. Whenever data changes, you get notified. You can also, there's equivalents for synchronization. So you know when synchronization occurred, whenever synchronization finished, and whether it succeeded or not. But typically, you shouldn't really have to care about that in most applications. And then finally, if we wanted to fetch those records from another instance, there's basically MIST.fetch all, MIST.fetch for a particular record or set of records, and then MIST.find, which is shown in a second. So MIST.fetch all, you provide the type of record and where you want to fetch it from. So your private cache, that'll get all the to-do lists. In this case, we know there's only one because we only saved one, so I just do dot first, and that gives us our grocery list, and we print it out. If we wanted to find the incomplete to-dos, we do MIST.find, records of type to-do, and then here you can provide a closure. Because all of this is backed by Realm, all of it uses generics, that means that the objects you get back are to-dos. They're not like records. That also means that this closure knows that it's a to-do. So you can do like property completion and stuff on it without having to cast it. So that's a way to find records. There's also a version of this with predicate if you like predicates instead of closures. And again, like with everything else, you say where you want to search for it, and that's going to give you the incomplete to-dos. And then I was showing that basically that now you have one of the to-dos, and you can mark it as completed and write it, and that way then write it again. There's also convenience functions on records, so that instead of doing MIST.fetch all records of type, you can just do to-do list.fetch all, and all the equivalents. And that is the gist of it. So it's not quite done. There's a whole bunch of rough edges. For instance, one of the things I didn't talk about is the public database, because it doesn't have these change notifications. You can sort of fake it, but it's more complicated. So I haven't built that, and I'm debating whether to do that or not, whether to even support access to the public DB, but I think a lot of people will want it. You guys can tell me if you ever want to use it. Whole bunch of other stuff, but that is the basic theory.
Is that a CloudKit limitation?
A CloudKit.
Does
Oh, yeah. So CloudKit doesn't allow custom record zones in the public database because the whole point of custom record zones is to guarantee atomicity, which they can't guarantee in the public database because potentially millions of people are trying to edit the same record at the same time.
Yeah.
And because of that, all the notification stuff that is based, it's like granular changes which are based on record zones, doesn't work in the public database. So you can create a query that describes what you want and then create a subscription for that query. So it'll tell you whenever it changes, but it won't give you the granular changes. So you'll have to get the full records again, which in many cases, like in this example, it doesn't matter. But obviously, if your full record has an asset, which is a 10 gigabyte video file, then it matters a lot. Yeah, doing that beautifully so that it would work for everyone is probably a lot more work than I'm willing to put in. But yeah, that's why that doesn't work. Anyway, there you go.
Do you have this as a pod, or what do you have?
Yeah, so I have kind of done a couple of different stabs at this. So the latest stab is definitely the right answer, but it is pretty early. So let's see, that's why. So it should be there. I kept moving things around because I had multiple ones called the same thing. So if it doesn't work, that means that I have accidentally moved it again. So I will fix it, and maybe Blake can send an email in the morning when I have it corrected. But yeah, you're welcome to take a look at it, and it should theoretically work. I'm sure it is very broken as well, and I would love your feedback as you try to use it. So I'm using it in my app that I'm building, but I'm pretty interactively building it and the app at the same time. And I have a buddy who's reworking an older app and using it as well. But
Having it a while will help.
yeah.